Does everybody have out worksheet 3? Need me to wait? We're talking about logarithmic functions today and introducing the idea of a log, okay? The whole reason we have logarithms is because we needed a way to find x when it's in the exponent, okay? The inverse of an exponential function is a logarithmic function. So if we had y equals 2 to the x, we'd graph it, and if we wanted log base 2 of x, we'd just do the inverse. We'd switch all the x and y ordered pairs. Does that seem okay? Remember, inverse reflects across the line y equals x, switches all the x and y ordered pairs, and switches the domain and range. So if we have an exponential sentence, we can switch it to a logarithmic sentence and back and forth. Is everybody remember the definition of a log? Okay, so if we have 6 cubed equals 216, does anybody remember how that rewrites as a log? Log base. The little number is called the base down there. And what is the base in this problem? The 6. Okay. Then the answer to the log is the exponent. So the answer to this is going to be the exponent 3. So the number we're taking the log of is 216. All right. I have a cute little video that helps us remember how that goes. I believe it uses b to the p equals n, which is log base b of n equals p or something. It uses base and power as the initials instead of, okay, let's see. All right, you have this on your notes. And this has us practicing a little. Where do I have the video? Maybe we should watch it now. Or not. Really? Did I put it on the wrong day's lesson? I very carefully found it. All right, we're going to stop this for a second. Base to the power equals a number, or the base of a number equals the power. So you're looking for the power when you do an exponent. All right, as I said, you are going to have to take a quiz on which you cannot use a calculator. You have to understand logarithms and be able to find some pretty basic values, okay? This book does not even have you rewrite any questions because it assumes you already know how to do that. We're just going to practice it a tiny bit, and I probably put one on the quiz just because it's easy points. But if you can't do this, you're in big trouble for the whole rest of this. How do you rewrite this as an exponent sentence? What did we just learn? 14 to the y equals x. Everybody okay? So this one would be? Okay. And to go in the other direction, this would be log base
A.
Yep, of
B.
the answer is the power or the exponent. So this one is log base 7 of all right, everybody good?
Yeah.
That should be review. Now, these are some basic properties that you should also know. The log base b of, so any base, the log of 1 is going to be 0 because it's saying b to the 0 power equals 1. So anything to the 0 power is 1, right? So the log of 1 is always 0 no matter what base it is. When the base and the number are the same, then you're talking about 1 because it's saying b to the 1 equals b. That's always true. So the log base, anything of that same number will be 1. This is a little more confusing. the easiest way for me to explain this is you guys remember this property from last year. When you have this, you can move the 2 out in front. Okay. So this is kind of the same thing as that one. Otherwise, if you rewrote this, it would be b to the x equals b to the x. Does that make sense? So this has to be just x. And b to the power of the log base b of x. Okay, I'm just going to leave this alone for a minute. How would you rewrite that as a log sentence? You'd write log base b of x equals whatever the box is, right? And the box was log base b of x. So does it make sense now when I rewrite it? What it's saying is when you have b to the power of the log base b, they cancel each other out and you just get x. All right, they undo each other. All right, so with those in mind, and they also are true whether it's log base 10 or log base e. Remember, when it's base e, it's called a natural logarithm. When it's base 10, it's called a common logarithm, where it's log and ln. All right, so let's try. These are written out on your paper. Everybody okay? The other thing is you can't take the log of a negative number, no matter what the base is. This is your little hint over here. If you have log base 7 of negative 3, it would be 7 to what power becomes negative 3? Can a power make something into a different sign? Can make it bigger or smaller, because if you have a negative exponent, right, then you would get a fraction, but this can't make it into a negative number. So you can't take the log of a negative number. All right, so these are the kind of questions that will be on the quiz with no calculator. So don't be touching your calculator. This is saying 5 to what power equals 1/25th, right? It's the way I think of that. Yes. 5 squared is 25. To put it in the denominator, it would be negative. Okay. This is 3 to what power is the square root of 3? You need to know that. It's the 1/2 power, okay? Square root is the 1/2 power. That's a really important one. That should come without thinking, okay? So this is 1/2 is the answer to that question. This is one, it's just 7 because the natural log of e is just 1, okay? If we rewrote this, yeah, can we just go there? What about this one, guys? Yep, this is just 5. Those cancel each other out, the log and the exponent. This one, because it's a 10 and a base 10 common log up here, is just 13. All right, try some more of these. Log base 7 of 7 would just be 1, because it's 7 to what power equals 7. All right, what's this one? It is 5x. It's kind of a weird answer, but... And this one? Just 2. This is not seeming like such a hard quiz, is it? Okay, what's going on here? 6 to the 6th is 36?
Oh, no. 2.
The exponent is 2. Everybody okay? You weren't the only one who said it. All right, this one I have to kind of think about. 3 to what power is 1/81? -4. Nicely done. And you just have to go, 3 times 3 is 9, times 3 is 27, times 3 is 81. You don't get a calculator, so it might take you a little bit. And then it's in the exponent, or in the denominator, I mean. Yeah, this one is just x squared. That's a weird answer, I agree, but... All right, do we need more practice? No? None of those look hard? Can we just talk about this last one? Yeah, 8 to the 5, base 8 512, that would just take me a long time because I think it's fourth, maybe. So the answer is 4.
Yeah.
Oh, maybe it is just 3. Yeah, I'm thinking 6. I was thinking 6 to the third is 216. Yeah, you're right. It's only 3. Okay, this is 16 to what power is the square root of 2? I would have to do a little finagling with that one. I would have to say to myself, this is 2 to the 4th. Okay, so this is 2 to the 4th to something equals 2 to the what? 1/2. So 4 times, right? Because you multiply exponents when they're power to a power. So 4 times something is 1/2. And I would look at it that way. Anybody know the answer to that? 1/8. Got to divide by 4, right? 1/2 divided by 4 is 1/2 times 1/4 is 1/8. Yikes. No. It has nothing to do with that, actually. All right. These are, which of these would you need a calculator for? Which of these make no sense? This is not possible, okay? But this one you can't do without a calculator, right? I don't know, 10 to some power to become that. This one you should all know. That will be a test question. I can just about guarantee it. Yeah, how many zeros? Okay. Yep. This would need a calculator. This would not, right? 4, what would this be? Can you rewrite that? It's in the denominator. It's not a cube root. Okay? So then the answer just is, can you get a negative number as an answer to a log question? Yes, you just can't take the log of a negative number. Okay? Can you get a negative here? Whatever, you'd have to type that one in your calculator. But this would be negative whatever the log of 9 is. All right. So the graph, these are the inverses of exponential functions. So if we had y equals 2 to the x, we'd graph the inverse would be log base 2 of x. And that you would switch the x and the y values then. Okay, so log 2 to the x would look like this, and it would reflect. It would have an asymptote, a vertical asymptote at the y-axis, which is x equals 0. Do you have this on your notes or not, the graphs? No? Okay. And transformations, remember it talks here, this is just a good reminder that horizontal transformations occur inside the parentheses and vertical transformations occur outside the parentheses. So if you had 3f of 1/2 x, no matter what the function was, this is a what? Vertical stretch. This is a horizontal, but remember it's the inverse of what it seems, or it's an actual stretch of 2. All right. So run me through these real fast. What's going on? Left, 4. This one's got 2 things. The negative out in front always reflects over x, and a -5 that's not in a parenthesis here, so it's on the whole thing would be down. Vertical or horizontal? Vertical stretch and left 2. Okay, you might have to do a little of that on your homework describing those. Okay, you do have this one. as an example, it is a base 6. It asks you to do the log base 6, okay? So it first graphs the log of 6 to the x, which is this one, and then it reverses the ordered pairs, and it goes through all these properties. The domain, this is the graph we're talking about now, okay, the log. So the domain is 0 to infinity. The range is all real numbers. The x-intercept is at 1, 0. The asymptote is the y-axis, or x equals 0. And it's approaching negative infinity on the left and positive infinity on the right, even though it's growing very slowly. It is always increasing from 0 to infinity. It has no negative values. All right, so let's try this. We're going to first talk about what graph. Do you not have this? Am I all messed up?
Yeah.
Oh. All right. I'll figure out what that was in a minute. Let's do this graphing. This says log base 3 of x. So right now, if I rewrote that, it would say 3 to the y equals x. Everybody okay? So the inverse of that would be y equals 3 to the x. That's supposed to be an exponent power. And then we're going to have log base 3 of x. All right, so I'm going to do it twice. I'm going to think about it as an exponent. If we had 3 to the x, it's a mess. Put some numbers in there for me. 3 to the 1. 3 to the 0. 3 to the negative 1. 3 to the 2.
9.
Okay? So if we graphed those, the original 3 to the x, not the function we're actually looking for, okay, would have been at 1, 3, which is off the chart, 0, 1, then up here, negative 1, 1/3, would have looked like this, okay? We're trying to graph the inverse of that. So the inverse of that switches all those ordered pairs. The log base 3 of x has the points 3, 1, 1, 0, 1/3, negative 1, 9, 2. So be careful. The scale on this is crazy. There's 3, 1, 1, 0, 1/3, negative 1 is clear down here. 6, 8, 9, 2 would be just off there. Okay, they use a really strange scale. And I'm not even going to hit those. Oh my goodness, I'm hopeless at this. I'm seriously hopeless. I can't hit any of them. I don't know. There we go. What are the values of domain? Anybody? 0 to infinity. Range is up and down, so it's negative infinity to infinity. Asymptote, there is one at what? Yes, it's a vertical asymptote at the y-axis, which is x equals 0. Intercept, there was an x-intercept only at 1, 0. End behavior, on the, as x approaches what? Be careful, x doesn't ever approach negative infinity. As x approaches 0, y approaches negative infinity. That's the left side. Everybody okay with that? kind of confusing. The right side would say as we get incredibly big, y will approach infinity. And is this graph increasing or decreasing? It is increasing on the interval 0 to infinity. Does not have negative values. And number 10 is a transformation of that graph. What are the two things that have changed over to this one? Okay, it is reflected over the x, and it is shifted right 2. Okay, so all of this value right here that was at 1, 0 is now shifted to the right 2, but it doesn't flip, right? Because it's right on the x. Okay. What about our asymptote here at x equals 0? That's going to shift to the right and be here. But these other points are not only going to shift to the right 2, they're going to flip. So if this one that was at 3, 1 moves to the right 2, it's now at 5, 1, but it's not. It's at 5, negative 1. And this one that was at 1/3, negative 1, moved to the right 2, so it's at 2 1/3, but instead of down at negative 1, it's up at positive 1. So can you fly through those things real fast? What's the domain of our new graph? You can't take the log of a negative number, so think about that. Can only be 2 or bigger, right? Whoops, that's supposed to be an infinity. The range, infinity to infinity, good. The intercepts had one at 3, 0. Asymptote at x equals 2. Very good, because it shifted to the right 2. That was our undefined place. What else do we have to have? End behavior as x approaches. Now, what is it approaching as it gets further and further to the left? Yep. As it approaches 2, the y value is getting incredibly negative. As it goes off to the right, it gets large. Nope, I just lied. I forgot we flipped it over. This one, as it approaches 2, it should have been positive infinity. And as it approaches large numbers, it is getting more and more negative. I totally forgot we flipped it over. Increasing or decreasing? Decreasing from where to where, though? 2 to infinity, yep. Okay. Don't hurt me, but there is one exponential function and one log graph without a calculator. Okay. It's base 2 or 3 or 4. It's nothing horrible. Okay. And I think it's even the same question. It says graph y equals 2 to the x and graph log base 2, the x right next to it. Do you get what I'm saying? That you just have to do the inverses. Not positive on that. I'll double check. Yes. How I got on number 9, this right here, I rewrote this 3 to the y equals x, and then I took the inverse. I just switched the x and y. Okay. These are inverses of each other, and it's easier for most students to generate ordered pairs for an exponential than it is to generate for the log. So if you generate the ones for the exponential and then just flip them around, you'll have the log. Does that help? We'll do some more. Yes.
No, never mind.
You sure?
Yeah, because I was going to ask
where do you get the 3 from in the second one, but you reflected it, and then I think I got it.
Here, this
Yeah.
3, this
Yeah.
point, because this point shifted
Yeah,
2 to the
shifted
right.
2, yeah.
Yep, okay. Yep, good questions though. All right. Is this the word problems from the front side or not?
No, that's the one.
All right, we'll figure out what was on the front in a minute. What? I didn't have. You have this one though? Okay. The annual growth rate for an investment can be found using this. Now, these are some kind of useless formulas because most of these you would use logarithms to solve rather than rewriting the formula like this, but they want you to practice using formulas. And it is a really, really good skill for ACT, both math and science. So where T is time in years, P is a present value, P sub 0 is the original investment. An investment of $4,000 was made. What does that mean? Original investment. So that number is going to go down here. In 2005 and became 7,500. So where's 7,500 going to go? That's what it's worth now. In 2010, so what's our time frame here? T is going to be a 5. Then I think we're good to go. R equals 1 over 5 times the log of, and we'll need some parentheses, 7,500 over 4,000. It is the natural log, so make sure you're using the right button. So if I type it like it's written, ln over here on the right, and it brings up a parenthesis. I'm guessing it's going to give us a decimal. Yep, 0.126 if I round. So what does that mean for the rate? Yep, 12.6% was the average growth rate. I don't know what you know about the markets today, but if you average 12.6%, I think you'd be really happy. Does anybody know what their savings account is earning right now? Yeah, it's really, really low. So 12.6% increase. If my retirement was earning that, I'd be thrilled. All right, is this the next one you have?
Yeah.
Okay, the doubling time. The time it takes for an investment to double can be given by this, where K is the interest rate written as a decimal. So if Tara's parents invested $5,000 in an account that earns 4.5% compounded continuously, will the investment double in 5 years? If not, what interest rate do they need? So, do we need to know that it's $5,000? For this formula, it doesn't matter. It says you just take the natural log of 2 divided by what? 0.045. What? And that's going to give us the time. Okay, will it double in 5 years is our question. So we're going to type this in and see, is it less than 5 or more than 5? Anybody, what'd you get? This is 15.4. So will her money have doubled? Not even close, right? How could we figure out what interest rate she needs to earn to be able to double it in 5 years? Can we just rearrange this formula? She wants 5 years here, right? So can't we just do a little rearranging of that? If we did K equals ln of 2 divided by 5, K would be what? Point something, I hope. 139, so she'd need almost 14%. Oh, that's some chicken scratch, sorry. But she'd need about 14% to double in 5 years. All right. I'm going to stop this recording, and then I will go back and see if I can figure out what those 2 questions were that we skipped on the front of the notes, okay?